Okay, we start with group 17 today. Now, what happened? The first point is group 17 elements, they are collectively called as halogens. They are collectively called as halogen. How did the name halogen come about? The name halogen came about from the Greek word hals. Hals, which means sea salt, and gens or genesis, which means to obtain from. To obtain from. It is a fact because one of the most important halogen, I mean, that is something which we are commonly aware. We are commonly aware that how do you get chlorine? One of the best sources of obtaining chlorine is you take from the sea water, evaporate the water, you will get sodium chloride, is clear? And then the electrolysis of sodium chloride will give you sodium and chlorine. So you got it from A. But many of you may not know how iodine is obtained. See what happens in the sea, there are certain seaweeds. These seaweeds have a tendency to absorb in their cells iodine. So you see in the Kutch area in India, what happens is that they collect this seaweed, pulverize it, make it into powder, and simply heat it and keep a iron or tin shed on that, because we know the property of iodine, that iodine sublimes. Iodine sublimes. So what happens? A layer of iodine will be formed on the, will condense on the iron sheet, and then they scrub it and remove it. Is this clear? Very crude way of making, but this is how they make it in India. Is this clear? So to some extent, even bromine can be obtained from seawater, because when you're purifying seawater, it's clear what happens is when you're purifying sodium chloride, whatever is a liquid remain, if you pass chlorine into that, bromine can be extracted. Is this clear? So one more idea what they do is, at least I have seen in Maharashtra, that there are certain companies using bromine. Okay, so they have what you call waste bromine coming out from it, and so from the waste we can also recover bromine. Yes, this is another way they are doing it. So we have genesis is to obtain from. Okay. Now, what happens is, what are the elements that we have? We have fluorine, chlorine, chlorine, bromine, iodine, fluorine, chlorine, bromine, iodine, and we have astatine. So I told you, this is the only atomic numbers I remember, because I told you, then we just go on subtracting 1 for the groups which are behind. You remember, like group 16. So this is what 9, 17, 35, 53, 85. 9, 17, 35, 53, 85. So what happens is, so the configuration will be 1s2, 2s2, 2p5. So outer electronic configuration is ns2, np5. So we have 1s2, 2s2, 2p6, 3s2, 3p5. So we have 1s2. Remember, 21 to 30, the 3D is getting filled. So here, 35 means for bromine, 3D will get filled. So you have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, and then what do we have? 4s2, 4p5. So here you have 57 to 71 was lanthanide. So a 4f was getting filled. So this is 53. So here 4f will not get filled. The first element in which 4f is getting filled is atomic number 57. So we have, this will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. We have 4d10 but not 4f14. So you have 5s2, 5p5. Then of course over here you will have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d10, 6s2, 6p5. So we come to the general question that we have to answer over here is the characteristic outer electronic configuration is the characteristic outer electronic configuration. Characteristic outer electronic configuration is ns2 np5. It is ns2 np5. Is this clear? So I just give about 2 minutes, take down that much, and then we'll start with the real stuff that we have to. Finished? Priya? Okay. Now we come to occurrence. See, when we are talking about occurrence, it is clear. Now, when we talk of fluorine, one thing is you always understand that they all occur in the combined state. That means there is no free state. It is clear. So that's the first point that we should know. Being reactive, they occur in the combined state. They occur in the combined state. That's the first point. Now, as far as fluorine is concerned, the most important minerals of fluorine are fluorine is important. I'll tell you why. We are going to study in great detail fluorine. Because first of all, it's the most reactive element, and because it is the most reactive element, what happens? Isolation of fluorine, that this is fluorine from its compound, took 50 years. And the first person who isolated fluorine in the free state was Henry Moissan. And Henry Moissan got a Nobel Prize for that. That is how difficult. 5 decades of research went into what you call isolating fluorine. Just like now, I told you chlorine, it's very simple. We just did electrolysis of sodium chloride to get Downs process. We got Downs process. We got sodium and chlorine separate, but not in case of fluorine. It was very, so how they did it and all, that's a different story. Just there. In fact, the method is called Moissan's method only. So now what happens? Being reactive, they occur in the combined state. So minerals of fluorine are what are the minerals of fluorine? You have fluorspar, and it is calcium fluoride first. Then the second one that we have is we have cryolite. Now, cryolite is something. Cryolite is Na3Al F6. Cryolite is very important because cryolite is a mineral which is, I mean, of course, nowadays you get synthetic cryolite. You don't get natural, we don't use. Synthetic cryolite is used in aluminium, huge scale in aluminium metallurgy. Is this clear? I mean, you can understand when I say aluminium metallurgy, the scale. Some 20 million tons of aluminium is, extracted. When this, I think, which one? This Vedanta group only is into that, Just now they're selling their the zinc plant and all that. So these fellows are into extraction business. In fact, now the third one is what? Third was Vedanta is the same person who is in trouble with the copper plant in Tamil Nadu. There's a serious problem there, Seriously, pollution is a problem. So third one is what? You have fluorapatite. Fluorapatite is 3Ca3PO4 whole twice CaF2. So these three minerals and their formula for fluorine is very, very important. So I told you, now this is by heart. Normally I told you I never believe in by hearting. But and for chlorine, seawater is the biggest source. So for chlorine, seawater is the biggest source. Then we have bromine. Bromine also we get from this thing, alkali and alkaline earth metals. From bromine is obtained from bromides of alkali and alkaline earth metal. Alkali and alkaline earth metal. Okay, alkali and alkaline earth metal. This is clear. Then the fourth I told you is iodine is obtained from seaweeds. Is obtained from seaweeds. Then the fifth one is astatine is radioactive. So now, whenever we are talking about astatine is radioactive, okay, you can have there was some talk about astatine. So what happens whenever you're talking halogens now onwards, we are only talking fluorine, chlorine, bromine, iodine. We are excluding astatine because of its radioactivity. So you take down this much and then I'll just check the half-life of astatine, whether it was ever asked. Eight hours. Okay. Half-life of astatine is radioactive. T half is 8 hours. This has been asked sometime. That's what I was checking the question. Priya, you tell me when you're finished, huh? Okay. Now, Shrestha, listen. Now, earlier, when we were talking about the periodicity in properties, I had, sometimes, I'm not very pressurizing on the PA. But in case of group 17, these periodicity in property play a very important role because much of this property has some connection to what you call physical property. So in this case, in group 17, the initial part is very important. There, we said, okay, oxygen is a diatomic molecule, oxygen, sulfur, selenium, tellurium. We very said easily, others are solid, this, that. But here in this case, the case of group 17, we have to pay a little more attention to that. Why? Because there is a lot of give scientific reason in that. And of course, that could also transform into a what you call a multiple choice question. How it will be, we'll see. So when we talk of physical state, it's fluorine. Fluorine is a gas. Okay, chlorine is a gas. Bromine is a liquid. I am not putting the color because color itself is another question. That a color becomes dark from this thing, what you call greenish, pale yellow to greenish yellow to reddish brown to violet lustrous solid. So that itself is a question which is asked, and why? Why? The answer is very important. So then we have fluorine, chlorine, bromine is a liquid. Bromine is a liquid. See, I'll tell you, I don't know if your board practicals are over. I mean, this should have been actually told much earlier. Now, what happens, and this is my experience as a what you call teacher in the college, in my years of college. When we are doing practicals, what happens? You add substance plus, let us say, MnO2 plus one drop. When we say one drop, what happens? Literally, the student adds 5-6 ml. One drop is one drop because we want the surface reaction to take place. Now, bromine is evolved. What student do now? Moment you see slight brown gas coming, stop it. They go on heating first of all. They make the whole environment filled with bromine because everybody is doing the same salt. Now, bromine, remember in life, has one big problem. Bromine destroys the mucosal lining. Bromine destroys the mucosal lining, and that damage is permanent. See, nobody does any study in India. Like, what could be the effect of COVID on those chemical workers who were exposed to bromine? You know why? Because if they did not have the mucosal lining, the mucosal lining is the first defense against virus attack. So if you see certain set of people have a pre-tendency, like those people who frequently suffer from flu, influenza, their mucosal lining is all weak because of continuous infection. If you see, they have all died in this COVID. Example is China. In China, normally because of the pollution there, huge pollution, what happens? People suffer from what you call lung problem, and that has affected. I mean, practically 80% of the country is infected with COVID. Of course, the second part is there was no vaccination, but these things have. So that's why I tell now when you're handling chemicals, Like normally in the industry, when we use bromine, we use a huge mask separately for that. Okay, there's a special mask. It's made by a company called 3M, the fellows who make Scotch Brite. Na? The American, they make 3M. So that mask has to be worn. But what happens here is people just handle carelessly. So bromine should not be handled carelessly because it will destroy permanently the mucosal membrane. This is clear. These are the complaints of certain industrial area. Na? Somebody must be leaking bromine. The people living near the area will have weak lung capacity, and something like COVID or something, they will die. Is clear? Especially that's why you should not, as far as possible, live near very in this chemical zone areas. Where that this is like Dombivli is a chemical zone area. Then Mahad, then you have Patal Ganga. All these areas. There are a lot of chemical plants. Living near that Vapi in Gujarat, and then Vapi Ankleshwar. So these are all chemical zone areas where living can be, what you call, harmful to health. This is clear. Because especially when it's chemical zone, if they say textile zone, we don't have to worry. Textile zone means like Tirupur, but textile also has its own problems because they use, if they're processing. If they are just weaving textile, then that should not be a problem. Solapur is an example where it's a textile zone, where they are making, what you call, weaving cloth, stitching, making final product. So that is not polluting industry. But chemical industry, you have to worry. So bromine, I told you. So in your exam, when you are doing a practical exam, substance plus 1 drop sulfuric acid, heat, slightest brown tinge. Finish, stop, don't try to breathe and see if it is bromine. It is not today that you will have a problem. When you are 50 years old and your lung capacity is weak, you will frequently fall ill for something you did in your 12th standard. It's a permanent damage to lungs. So that's the aim of teaching these chapters. You must be wondering, exam has its own importance in life. You get marks, you become something, whatever it is. But the other idea of teaching you this is knowledge addition in your life. So bromine is a liquid, iodine is solid. So what happens is, now we are coming to those elements whose atomic mass is more. So if you look at sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, what happens? The last element, the 17th group element, the mass is also higher. So if it is diatomic molecule, the mass being higher, what happens? They have what you call huge van der Waals forces. So as we go down, what happens? The sheer increase of the van der Waals force of attraction. What happens over here? What is the reason? The increase in van der Waals force of attraction, van der Waals force of attraction increases the agglomeration. Increases the agglomeration. Increases the agglomeration, and what happens? The physical state changes from gas to solid. So there is no other reason. Simple, the weight increases. Of course, the number of electron increases, the number of proton increases. That they have to increase the weight. And that increases the van der Waals force. This is called as agglomeration. From gaseous state to solid to it. As we move down the gas to solid, as we move down in the group, as we move down the group. This is one of the most interesting of all the inorganic. A lot of things we have to teach. Atomic area, atomic size, and atomic area. See, try to understand physical state. Second is, we have atomic and ionic radii. So what happens is, in the period to which they belong, see, let us take what happens is, if you look at the atomic size, normally you will think, okay, the atomic size decreases. Atomic size decreases. So in a period, I'm talking about period, group, and then all that I'll talk. In a period to which they belong, what happens? They have the smallest atomic size. They have the smallest atomic. Now you will say, sir, how can it be? It is the inert gas which you ask, because we can make a general statement that as we go down in a period, the atomic size decreases. So by that general statement, what happens? We are saying that general statement says that last element will be the inert gas. People will always say that then inert gas should have had the smallest atomic size. But what happens in an inert gas? What happens? The electrons are completely filled, and what happens because of the electron repulsion, the paired electron repulsion? What happens? The atomic size of the inert gas is slightly greater than that of the corresponding halogen. So therefore, the credit for being the element with smallest atomic size goes to halogen. So this is the MCQ. It is clear, because if they put halogen, inert gas, something else, two more distractors, you might think it decreases as we go down the group, because I know your story has been taught, electrons add into the same shell and all that. But the problem is that what? Okay, the atomic size of inert gas is slightly more than that of the corresponding halogen. So halogen gets the credit of being the smallest atomic size in the period to which they belong. That's the first point. Second is what? As we go down the group, what happens? The atomic size increases. Then what happens? The third one, okay, ionic size. So what happens here is they have 7 electrons in the outermost shell. So tendency is to accept 1 electron and form anion. So whenever we are talking about ionic radii, it is the anionic radii, and generally the anionic radii is greater than the corresponding atomic radii. Exactly, that's the first thing. So what happens? The anionic radii, the third point is the anionic radii is greater than corresponding atomic radii. Is greater than the corresponding atomic radii. The fourth point is what? The fourth point is anionic radii. The anionic radii, what happens? Increases as we go down the group. The reasons are same. That is simply the number of electrons are increasing, so that is going to happen. Is this clear? Write down this much. So next will be ionization enthalpy, very important. Okay, great. Now what do we come to? Ionization enthalpy. Very important. See how ionization enthalpy is going to affect the properties. Up to now we always said it's only increasing, decreasing and all that. Na? But here it's going to matter. So what we have, listens carefully. We are talking about ionization enthalpy. So when you're talking of ionization enthalpy, what do we know? We know that as we go down, I mean, as atomic size decreases, since this is the smallest size, they have the highest ionization enthalpy. Because if size is small, it's going to be very difficult to remove the electron. Is this point clear? So what happens is ionization enthalpy. Ionization enthalpy, what happens? Is maximum. I am not saying it is maximum in the sense in the period. Why? Because then we'll get into trouble with inert gases. Inert gas has the maximum ionization enthalpy. Ionization is maximum in the period except for corresponding inert gas. Leave that. Otherwise, what happens? You will find that ionization enthalpy is maximum. Now, what happens as we go down the group? That is a very important point. Now, there are two MCQs which they can ask. It is clear. They can create. So, and they have been asked. It's not that they can ask. I am not nobody to tell that they'll ask. These are questions. That's what I said. Sometimes they revise. What question did they ask on this? I've got a data. I'll just check. Like I told you, astatine. Sometimes some fellow had asked in some PMT exam, astatine ka half-life, 8 hours. Because those days, we used to have nuclear chemistry also in the syllabus, which we now have in advanced JE. Is this clear? All the half-life and all that is there. Binding energy by binding energy per nucleon and all that. So NEET we don't have. So ionization enthalpy is maximum in the period except for corresponding inert gases. As we go down the group, what happens? As we go down the group, ionization enthalpy decreases. Ionization enthalpy decreases. So when ionization enthalpy decreases, how does it affect the physical properties? So we have, it affects the color. It affects the color. Look at fluorine now. Fluorine is pale yellow gas. Pale yellow gas. Chlorine is greenish yellow gas. Greenish yellow gas. Bromine is reddish brown liquid. It is reddish brown liquid. Iodine is, surprisingly, I'll tell you, iodine is violet, lustrous, solid. So what can you see? The first effect of decrease in ionization enthalpy is the deepening of color. Is the deepening of color. From pale yellow to greenish yellow to reddish brown to violet, lustrous, solid. Now, this is a set of group of non-metals. Fluorine, chlorine, bromine, iodine. These are perfectly non-metals. Nobody has said it's a metal. But because of the decrease in ionization enthalpy, you find that certain metallic property like luster. So, I mean, give scientific reason. That's GSR, okay? GSR is what? Iodine shows luster. So luster or shine is a property, what do you call, exclusive to metals. Exclusive to metal. Gold shines. The value is that. Na? So there's a big fight. Is dollar more secure or gold? You can see that gold is more secure. Is this clear? Life may, if we keep fixed deposit, stock, Adani shares, this, that, whatever, anything can go haywire. But gold, intrinsic value, it does not lose. It may just, what do you call, it may not appreciate very much. Is this clear? See, I'll tell you, when I was, maybe I was in the third standard or fourth standard, 10 grams of gold was 80 rupees. I'm born 1961. So I'm talking about 65, 66, 67. That time, gold was only 80 rupees for 10 grams. Is this clear? Then I think in 2015, it was around 6,000 to 7,000. And 2022, it is, I think, nearly touching 57,000 rupees for 10 grams. So if you look at it over a period of time, it has appreciated. Okay. But it's not like these shares that you bought it at 3,000 has become 1,500 today. If you bought it at 6,000, it has gone up. It has not become 4,000. So that is what we mean by intrinsic value in A. So gold is gold standard. Is clear. So iodine shows luster. Luster is A. That is because ionization enthalpy of what iodine is less. So when the ionization enthalpy is less, what happens? You have, what do you call, electron can move out easily. When sunlight falls on it, electron jumps and falls back, and that creates luster. Okay, so take down this much. Next we come to is electron gain enthalpy. No, we'll talk about electronegativity and then electron gain enthalpy. Okay, great. Now when we come to electron, not much to discuss. Electron gain enthalpy, we have a lot to discuss. So when we talk of electronegativity, yes, but then there will be a anomalous behavior. Na? I'm coming to that. Fluorine has a electron gain enthalpy less than that of chlorine. We look at the values, and that becomes a give scientific reason. Then decreasing order and all that is there. No, first we'll talk electronegativity because there's a slight connection between the two. So I would rather take electronegativity first. So when you talk of electronegativity, what happens is, listen carefully. When you talk of electronegativity, they are the most electronegative element in the period to which they belong. First point, electronegativity increases as we move in a period. Is this clear? So first point is, halogens they are the most electronegative. They are the most electronegative. They are the most electronegative element in the period to which they belong. In the period to which they belong. In the period to which they belong. Is this point clear? Then the second point that we come across is most important. Fluorine is the most electronegative element. Fluorine is the most electronegative element. Fluorine is the most electronegative element in the complete periodic table. In the complete periodic table. And there are different ways of measuring the electronegativity. One is the Pauling scale. Is this clear? So in Pauling scale or Pauling, Linus Pauling. So the pronunciations are different according to culture. So we have Pauling scale equal to 4. A very interesting thing happened. There was in Wall Street Journal, there was a article. My brother-in-law happened to read that in some state in some school in some state, what I can tell you the state also, in America, they don't have chemistry teachers. So he just said, look, there is chemistry teacher shortage here also, it seems. So what I did, I just found out the name of the person, and then which college it, and I just decided, let us try something, and I just sent him an email, that I'm ready to teach American children free online, sitting in India. I have no energy to go anywhere. So I just did it, because this problem is that we are going to face the problem here also. The problem is that nobody is taking pure science, first of all, and nobody is taking chemistry, because the 12th chemistry is so exhausting that people think, why take chemistry? Like, at least in the urban areas, computer science, information technology seems to be more what you call relevant, popular, because there's an instant job available. But rural areas where I told you, these chemical zones are there people take chemistry because jobs are available. But people are not willing to study chemistry. So I just threw a stone and said, let us see what if the Americans want help. So there are no chemistry teachers available even in America. So I am a very rare species. That's a very comforting thing in life. So fluorine is the most electronegative element in the complete periodic table. Pauling scale is 4. Okay, so there are different scales. Pauling scale. So from the NEET point of view, today in the night we'll revise your 11th standard. Okay, what are the 4 scales? It is clear, and how we are calculating it equal to 4. And the highest value is 4. So we will have chlorine is 4. Chlorine will be equal to what? 3.3. Then bromine is 2.8 and iodine is 2.5. There's a relevance. I'm just mentioning this because there's a relevance to something we are going to come across in a later stage. This has a relevance to the in why it forms interhalogen compounds. So one of the answer is the large difference in electronegativity. So 4 and 3 will be 1, 4 and 2 point is 1.2 and 4 and 2.5 is 1.5. So this large difference in electronegativity allows the freedom of one halogen to combine with another halogen. We don't see this in the what you call alkali metals. Does sodium combine with potassium? No. Sodium may form an alloy with potassium. Alloy is a physical mixture, remember that. But sodium does not chemically combine with, because what is the reason? We say elements in the same group have similar chemical properties. So combination is because of chemical property. But the exception to the rule is in this case, they may combine among themselves, form what we call as interhalogen compound. And one of the reason attributed to why it happens like this is because difference in electron. That's why electronegativity is different. Okay. Then they are most electronegative element, the period. And electronegativity, of course, we have the third point we can see here. Electronegativity decreases as we go down the group. Electronegativity decreases as we go down the group. As we go down the group. Then what do we have? The next is electron gain enthalpy. As you were asking me, absolutely, the question is very clear. What is it? And what you asked me was very correct. That since they have 7 electrons in the outermost shell, since they have 7 electrons in the outermost shell, what happens? They would always yearn to have one more electron complete the octet. So when they take one electron, what happens? From a gaseous atom, it becomes a gaseous anion. And the anion has to be stable. If the anion has to be stable, correct, it should have less potential energy. And when it has less potential energy, how will it decrease the potential energy? By giving out heat energy. By giving out heat energy. Generally, I told you, except for inert gases and that S to S minus 2 and O to O minus 2, electron gain enthalpy generally, I am not saying absolutely. So understand the English part of it. That's another problem. Basically, in this generation that we are finding, I mean, there's a huge resistance to teachers who are teaching in English. I mean, it is a commercial language. You have no choice. Basically, if you don't know English, survival is difficult. Okay. I mean, we have a problem in our software company that if you put a developer across a client and the client speaks in English, this guy is not able to take down notes about the requirement of the client. So that's where things go wrong. So what I was telling you was, I told you that about electron gain enthalpy. Generally, not absolutely. Absolutely means in all cases. Generally means most of the cases. Electron gain enthalpy is exothermic. Heat is energy is released. Except those two cases, oxygen O to O minus 2 and S to S minus 2, that is endothermic. And of course, for what do you call noble inert gases, it could be what do you call endothermic, because already it is 8. Why you want to put one more electron? Then you have to put more heat to make that electron, put that electron, no? But here, it is exothermic in all cases. So, when you talk of electron gain enthalpy, what happens is, okay, all electron gain enthalpy of all elements, electron gain enthalpy of all elements is exothermic. So in this case, it is exothermic. I told you the question they will ask is, they'll give 3 halogen, F to F minus 1, Cl to Cl minus 1, Br to Br minus 1, and then O to O minus 2, which is endothermic. O to O minus 2, S to S minus 2, are very two classic cases. And they've asked many a times this, and that's why I'm repeatedly telling, I'm not boring you. I'm trying to inculcate this in your mind that there, in that 1 minute, in 10 seconds, it strikes that I had said this in the class. And that 10 second is about 50 seconds saved for the next question. That is how it is. So here everything is exothermic, but in the other case, oxygen, sulfur, selenium, tellurium, polonium, O to O minus 2 and S to S minus 2 was endothermic. Okay, comparative study we have to do. But then what happens is, okay, now here GSR, give scientific reason. That will also become a what do you call entrance exam question. How it is, I'm going to discuss. Give scientific reason. Fluorine has, okay, I'll just write down the value. So it becomes more what do you call, we have the values with us. So it becomes more apparent, you will understand what I'm saying. Okay. So when we talk, it's exothermic, we know. So electron gain enthalpy in kilojoule. So it's in kilojoule per mole. What happens? You have fluorine, chlorine, bromine, iodine, and do we have astatine? We are not discussing astatine. Fluorine will have minus 328 kilojoule per mole. Then our friend will be minus 349. Bromine will be minus 325, and this will be minus 296. Okay, kilojoule per mole. So you can see this is 349. So this should have been more than 349. Then you would have had the rule that electron gain enthalpy decreases as we go down the group. Electron gain enthalpy decreases as we go down the group. Correct? Yes or no? But there is anomalous behavior here. That is what we have to attack. So what happens is the decreasing order. So what is a NEET JEE question that we can have? Very predominantly this is decreasing order of electron gain enthalpy. Decreasing order of delta electron gain enthalpy H. It is what? It is chlorine greater than fluorine greater than bromine greater than iodine. Remember that. It is not fluorine greater than, so it's not perfect decrease. So there's anomalous behavior. So fluorine has, so I will attempt over here. Easy for me to. So give GSR, give scientific reason. Fluorine has electron gain enthalpy. Fluorine has electron gain enthalpy less than that of chlorine. So it's anomalous behavior. Why? The answer is, first of all, fluorine has a small atomic size. Like I always give an example, it's not very relevant, but very apt. That is, if suppose you have a one-room kitchen flat, Bombay made, it's very common. It's clear. The low middle class and the middle class also these days are staying like that only because cost is very high. It is clear. I mean, the real estate prices are very high. So, what will they do? But imagine in a situation where there is father-in-law, mother-in-law, and two brothers having their wives in the same small space. What is going to happen? You will have a TV serial of 2000 episodes. Ghar Ghar Ki Kahani. You can have this fellow plotting, that fellow hitting, this fellow trying to do something. That is what? Disturbance, no? So here same thing happens. Fluorine.
So we don't take the negative value.
Beta, negative value. Did I put negative? Yes, I put the negative value. Negative value is an indication. The enthalpy change is negative, means it's exothermic. Corresponds to the earlier statement that I given.
So we just look at the absolute value, right?
Yeah. Absolutely. The negative sign. No. We are not going by the number line method. The negative sign here just indicates its exothermic nature.
Yes, sir.
Okay.
Yes, sir, I forgot about
No, good. What am I there for here? This is what my job is. Maybe the other Shresh did not realize it. You asked it, so he has also realized that this is what it is. The negative sign indicates that it is exothermic. Then the absolute values are taken. Okay. That's what is my job, to correct all these things. Na? We are the fag end of the year. We should know all these things. So, we were talking about what? So, we have come to here. That since fluorine has a small atomic size, what happens? There is a strong repulsion. there is a strong repulsion between the outermost electron. Outermost and the incoming electron. Outermost and the incoming electron. So there's a strong repulsion. But you see, now you're having two contradictory problems. What are the two contradictory things that you're having? On one hand, fluorine wants to become fluoride. It wants to complete its octet. But on the other hand, what is it facing? There are 7 electrons too close by. They are also repelling the fellow who is incoming. Look at the contrasting. So some energy, suppose it was maybe able to release 370 kilojoule. Some 40 kilojoule it will use to stabilize the anion. So when the net you see how much is what you call released, it's 328. So what happens? It becomes less than 349. It should have maybe released much more, but some of the energy is used. So what happens? The third point. The third point is, so some energy is used to overcome the repulsion. Some energy is used to overcome the repulsion. Okay, when it's used to overcome the repulsion, what happens? The electron gain enthalpy. The electron gain enthalpy of fluorine is less than 12. So this is not true for chlorine, because by the time the atomic size increases, when the atomic size increases, what happens? Automatically the repulsion between the outer electron and the incoming electron decreases, so there is not much energy used to stabilize the anion. So this is a very important point. Please take down. Shreyash, it is you only joining again or the next student? Because we have batch of, it is you only. The next we are going to talk about is oxidation state. I told you, see, technically, let's take a number. Fluorine accepts an electron to become fluoride ion. In the normal course, it would have given about 378 kilojoule per mole. But what is actually giving is 328 kilojoule per mole. That means what? Nearly 50 kilojoule has become less. Where did that 50 kilojoule go? That was the energy used to make the incoming electron, to overcome the repulsion. So it is not using energy from some outside. That is not possible. Fluorine is becoming fluoride, and that electron is using the energy being released to overcome the repulsion and become fluoride ion. So the net energy released becomes less. That becomes 328. If this problem was not there, then this would have been probably 378. So maybe 50 kilojoule more, and then we'd have had a very standard story to talk about that it decreases as we go down the group. It is not. Fluorine seems to be having an unusually lower amount of electron gain enthalpy than what it is supposed to. And the reason is this, that it's using its own energy. Atmanirbhar, you know what they are saying. Internal energy, internal resource only it is using to overcome the repulsion. You got the point? It's not getting energy from outside. It's recycling the energy inside. Okay?
Yes, so this is the reason the energy is used.
Yes. Some amount is used up. Now, so then the net energy released will be less. Yeah, no problem, no problem. We have one more very important point, that is oxidation state. So that completes one physical trend. Then we have chemical trend tomorrow. So for those who are on the live stream with me, okay, there will be a lecture tomorrow at 6:30, 6:30 to 7:30. Please join. So now we come to what we call as oxidation state. I am not for my regular students. I am not here in Bombay from on Tuesday, Wednesday, Thursday, Friday, Saturday. I'm coming back, but then the next lecture will be after Monday, tomorrow. The next lecture will be on next Sunday only. Is this clear? I am going to Kota to attend a marriage, and then look at the scene out there. What is happening? We hear Kota. I have not gone. My son has gone there. Always he goes for all the work. So I have not gone. Let me see the scene out there. As a teacher, Kota looks like a pilgrimage for all teachers, like Varanasi and all that. So let us see. I want to just go. So marriage is an excuse. Okay. And of course, I'm going to enjoy very good Rajasthani food. So, I mean, one of our chief developers of the company, her brother is getting married. So that's why I'm going. She has been with us for the last 5 years. And she's done a lot of job. All these things is developed by her only. All our Edumate Plus platform for MCQs, all that has been developed by her. So listen, even Scorer Plus, which you have been using. So now listen carefully. So what I was telling was, we were talking about oxidation state. The thing is, fluorine, all halogen. Let us start like this. All halogen show an oxidation state. They show an oxidation state of -1 in halides. They show an oxidation state of -1 in halide. But what happens again? What happens is fluorine always shows. Now this always is a very important word, because that gives rise to one give scientific reason. Is this clear? Fluorine always shows an oxidation state of -1 only. Please try to understand, we are using adjectives to explain this. Is it clear? Always and only. Is it clear? Now, always shows an oxidation state of 1 only. That is give scientific reason now. Give scientific reason. First of all, A, why is it so? Fluorine has the highest electronegativity. So it's not going to give electron. It is always going to grab electron, because it's the most electronegative element in the complete periodic table. Is this clear? B, what happens is, the reason is fluorine does not have a vacant D subshell. Fluorine does not have a vacant D subshell. Is this clear? Now, what about the other? What about other? So now what happens is, other halogens So one thing is very clear, they'll always show -1. They'll always show -1. Means 1 in halides. Fluorine will always show -1, correct? Then there's a slight question. Now, what do the others show? Do they show any other oxidation state? Yes. Other halogens, when we say other halogen, we are talking about what other halogen? Chlorine, bromine, and iodine. The other halogen, that is chlorine, bromine, iodine. Just a minute, because this phone may just slip. The other halogen, fluorine, chlorine, bromine, can show or may show, can show +1, +3, +5, +7. Oxidation state. State in. So now they are showing a positive oxidation state. They can show positive oxidation state in what? In first of all, interhalogen compound. Interhalogen compounds and oxides. See, oxygen is more electronegative than chlorine. Now remember that. If fluorine has 3, oxygen has an electronegativity of 3.5. Chlorine has 3. So chlorine and oxygen can also combine and form what you call oxide. So bromine, all this. So here in this, for example, what are interhalogen compounds? I told you, normally within a group, what happens? They do not, what do you call? They do not, normally they don't combine. Like sodium, potassium, I told you. The best example, they form alloys, but they don't chemically combine. But because of, so that's a question we are going to see later, but I'm repeating, I'm explaining here and repeating it there. This is a tendency of what you call halogen. Halogens tend to combine among themselves. Halogen tend to combine among themselves. Fluorine and chlorine, fluorine and bromine, fluorine and iodine, iodine heptafluoride, all that. And form what? Bromine pentafluoride. We did see nature of chemical bond, the structure also. What was the hybridization? What was the structure? So such compounds exist. That's why we studied the structure. These were interhalogen compounds. These were, why did they form interhalogen compounds? Large difference in atomic size and large difference in electronegativity. Same is the case with oxide. It is clear. We have what do you call Cl2O7, ClO, chlorine monoxide. So oxygen is -2, so chlorine will have +2, something like that, So we have, but mainly it shows +1, +3, +5, +7. Okay. Why? I'm going to dictate it again in interhalogen compounds, chemical properties. Okay. In interhalogen compounds, is this clear? I think that's all. You can take down this and we stop here, okay, today. So tomorrow I'm going to take on the chemical properties and then we will come to compounds, that is chlorine and hydrogen chloride, interhalogen compounds and oxyacids of halogen. So tomorrow we'll tackle chemical properties. So when you finish, you leave the portal